Section 5.4.19. The data represent the number of driving fatalities for a certain area by age or for female and male drivers. If you look here, we have the first column represents male, second column represents female. Under 16 is the first row, 16 to 20 is the second row, and so on, all the way to 70 and over. For the first part, it says, what is the probability that a randomly selected driver fatality who was male was 35 to 54 years old? So what we're doing here is we're trying to find the probability that event F is occurring when event E has already occurred. Well, that is the same thing as saying that N of E and F divided by the probability of E. Okay, so what does the probability of E and F mean? Well, that is the male victims who were in the ages from 35 to 54 years old. Okay, and then we're dividing it by the total male victims. Okay, so what we want to do is we want to be able to look here. Now we can see here that the total for the male victims, we need to add up all of these values here. So when we add that up, we end up getting a total of 39,811. Okay, so what does that represent? Well, then that represents our denominator, which means that we have a total of 39,811. Okay, and then how many of the male victims who were 35 to 54 years old? So if we take a look at that, how many of the male that were 35 to 54 years old is 12,728. Okay, so now we need to figure out what happens when we simplify that. So let's go ahead and do that. So we got 12,728, divide that by 39811, and we get 0.319. So we're going to approximate that to 0.319, and then we're going to round that to 2 decimal places to get 0.32. So now we can answer this question by saying the probability that a randomly selected driver fatality who was male was 35 to 54 years old is approximately 0.32, or 32%. Okay, next, what is the probability that a randomly selected driver fatality who was 35 to 54 was male? So a little different question here. So what we want to do is, again, we're finding the probability of event F occurring when E has already occurred. Okay, so that means we have N, and that's E and F, over the probability of event E. Okay, so again, what is the probability that a randomly selected driver fatality who was 35 to 54 was male? So in the numerator, when we have E and F, what we're looking at are the male victims who were 35 to 54 years old. and then we want to divide it by the number of victims who were 35 to 54 years old. So we're looking at the number of victims who were 35 to 54 years old. Okay, now we can figure out what the numerator is because we know the male victims who were 35 to 54. We know from the previous step, we know that that's 12,728. Okay, and so now what we want to do is we want to be able to figure out what are the victims who are 35 to 54 years old. Well, we look here, we're going to add up these two. So that means we want to be able to add up to find out what are the victims of those. So that means if we add these two together, 12,728 plus 4,714, when we add them together, it's going to give us 17,422. So that means down here, it's going to be out of 17,422. Okay, so now we're going to go ahead and do the math there. So let's go ahead and do that. So if we take 12,728, divide that by 17,422, and that gives us the following, 0.730. So approximately 0.730, and we'll round that to 2 decimal places, which gives us 0.73. So now we can then conclude by saying that the probability that a randomly selected driver fatality who was 35 to 54 was male is approximately 0.73. Okay, last question says, is a victim of a fatal accident aged 35 to 54 more likely to be male or female? And then choose the correct statement below. Well, first and foremost, we know what the probability of it is to be male. Okay, that was in part B. So we know that the probability of male in our problem is 0.73. So if we wanted to find the probability of female, then we would find the complement. That would be 1 minus the probability of the male. Well, what would that equal? That would be 1 minus 0.73, which is equal to 0.27. Okay, so what does that tell us? Well, that tells us, therefore, it is more likely that the victim was male, which is the probability of 0.73, than female, the probability of 0.27, because the probability of that event is higher. So then we would say the following. We would say that the driver is more likely to be male because the probability is greater than 50%, which is 0.73. Now keep in mind that some of these problems may ask you to round to 3 decimal places. In this question, we round it to 2 decimal places. But if it says to round to 3 decimal places, just be careful when you're going through that.